Welcome to Himani Coaching Center. We are committed to simplify concepts and amplify confidence of all the students who are watching our videos and learning maths, physics, and chemistry through these videos. So, students, today we are covering chapter Congruency of Triangles for class ninth, both CBSE as well as ICSE board students. So, when we talk about congruency, let us quickly revise how do we prove two triangles to be congruent. So, two triangles are congruent if their corresponding sides are equal, corresponding angles are equal. Okay. Now, if we are given, let us say we are given two triangles, let us say ABC and PQR, such that AB equals PQ, BC equals QR, and AC equals PR. So then these triangles are congruent by SSS theorem, side theorem. And once we prove triangles to be congruent, the corresponding parts automatically become congruent. So angle ABC will become equal to angle PQR, angle BAC will become equal to angle QPR. Similarly, angle ACB will become equal to angle PRQ, and for that we use a term called CPCTC. Corresponding parts of congruent triangles are congruent. You just remember CPCTC. So whenever we prove two triangles congruent, we can prove other things equal by using CPCTC. The other method of proving two triangles congruent is if we have triangle, let us say ABC and PQR, in which AB is equal to PQ, side BC is equal to QR, and the angle included between the side. So if you look at AB and BC, B is the common angle, PQ and QR, Q is the common angle. And if these angles are also equal, then the triangles are congruent by SAS. Okay. Remember, the angle has to be the included angle only. Let us say, just for understanding that what is not possible. So let us say I had given AB equals PQ, BC equals QR, and we were given this. Then we cannot say SAS. Okay, there is these triangles for now are not congruent. Okay, keep this thing in mind. The angle has to be the included angle. Then the other method by which we can prove two triangles to be congruent is, let us quickly draw ABC triangle and PQR triangle, and let us suppose angle ABC is equal to angle PQR and angle ACB is equal to angle PRQ, and side BC and QR are equal. Then these triangles are congruent by ASA. Okay, how do we write congruent? So we will write triangle ABC is congruent to triangle PQR, and then we will write by ASA, angle side angle theorem. Now see, if two angles, corresponding angles are equal of two triangles, then automatically third angle will be equal. Just for understanding, let us say this angle is 50, this is also 50, and let us say this angle is 60, then this is also 60. Now with angle sum property, what would be the value of this angle? 70 degree. Even this would be 70. Okay, so we can use a theorem which is called AAS. What does that mean? So we can just take triangles, okay, ABC and PQR. Let us suppose I am saying this angle equals this angle and this angle equals this angle, and I am saying this side is equal to this side. So we can say that these triangles are congruent by AAS theorem. AAS is possible. Why? Because by angle sum property, these angles are bound to be equal. So we need not show this step, because if you show this step and prove these angle equal, then it is ASA. But we can ignore, or we can decide not to write this, but simply write that these triangles are congruent by AAS. Okay. Now the last theorem is to do with right angle triangles. So if we have got two right angle triangles, Okay, right angle means 90 degree. So 90 degree at B, 90 degree at Q, and their hypotenuse are equal. That's important, huh? So hypotenuse are equal, and any other pair of corresponding sides are equal. Let us say this is equal to this, or it could be AB equals PQ. Then these triangles are congruent by RHS, right hypotenuse side. Right means right angle, H hypotenuse, and any side. So two right angle triangle in this case would be congruent by RHS. Please remember, not all the right angle triangles will be congruent by RHS. It could be any of the other theorems as well. Okay, so you see a right angle triangle, don't jump to make it RHS. Okay, you will have to read the question. Now let us look at the question. We are given in the given figure AC is equal to AE, AB equals AD, angle BAD is equal to angle EAC. We are supposed to prove BC is equal to DE. Okay. Now see, we are given this angle and this angle are equal. Okay. So we are given angle BAD is equal to angle EAC. Okay. Now, if you pay attention, this angle is between both the angles, which is angle DAC. So, if these two angles are equal, and if I say angle BAD plus angle DAC, it should be equal to angle EAC plus angle DAC. Correct? Mathematically, we are adding both same numbers on both sides, so that is possible. Now, if you look at the angle which is made by BAD and this angle DAC, that name is BAC. So what are we saying now? That angle BAC equals, and if you look at this angle, the name is angle EAD. So we have proved that angle BAC and angle EAD are equal with this information. Okay. Other things given are AC equals AE and AB equals AD. Now, let us look at triangle BAC and triangle EAD. Okay, let us look at triangle BAC and triangle EAD. Now, we are already given AC equals AE. We just proved angle BAC is equal to angle EAD. Yeah, this is given to us, so you will write reason as given. This you will write proved above, which we just proved, and then AB is equal to AD. Again, this is given to us. So now, how are these triangles congruent? Just see SAS. So we will simply say triangle BAC is congruent to triangle EAD by SAS theorem, and because of that BC is equal to DE by CPCTC. Okay, so pause the video and write down the solution. Also, once you are done, do try solving this question on your own. Okay, now let us move to the next question. Here we are given a diagram in which ABCD is a parallelogram. What is property of a parallelogram, students? Opposite sides are equal as well as parallel. Okay. ABL is a line segment and E is midpoint of BC. Now E is midpoint of BC means BE is equal to EC. Okay, because E is midpoint. Okay. Now we are asked to prove triangle DCE is congruent to triangle LBE. Then AB is equal to BL, and then AL equals twice of DC. So let us look at the triangles. So let us look at this point E. This angle and this angle are equal. Why? Vertically opposite angle. So let us write that down. So we will say in triangle DCE and LBE, and okay, triangle DCE and triangle LBE. We are writing that angle DEC is equal to angle BEL. Why? Vertically opposite angles. They are equal. Then we are given BE equals EC. That is given to us. Given E is midpoint of BC. Then, since the lines are parallel, so in parallel lines, what kind of angles are there? Alternate interior angles and corresponding. Okay, alternate interior angles, look at this shape. So this angle Z shape, Z or reverse Z, those are alternate interior angles in parallel lines. Okay, so here you can see that this angle and this angle, which is angle DCE, is equal to angle LBE, alternate interior angles. So now what are we saying? We are saying triangle DCE is congruent to triangle LBE by ASA. Okay, angle side angle. Once that happens, then what will happen? Then DC will become equal to BL by CPCTC. Okay, but DC is equal to AB. Why? Opposite sides of parallelogram. Okay, opposite sides of parallelogram. So we can say that AB is equal to BL. Okay, so now we have proved that AB is equal to BL. Let me remove this. You can rewind and watch this video again for this calculation. So we are done with the first two proofs. Now let us go to the last one. Last one, they are saying prove that AL is equal to twice of DC, which is also very simple. See, if you look at the diagram, AL is what? It is equal to AB plus BL. Okay, AB is equal to DC. Okay, and BL is also equal to DC. So AL is equal to twice of DC. That's how we prove this part of the question. Now let us look at the last question for today's video. We are given this figure in which AB is equal to DB and AC equals DC. And they are saying angle ABD is this full angle is 58 degree. Angle DBC, which is just this angle, okay, is 2x minus 4. So 2x minus 4. Angle ACB, which is this angle, is y plus 15. Okay, and angle DCB, which is this angle, is 63 degree. Find the value of x and y. Now, before we solve, just look at the triangles ABC and DBC. AB is equal to BD given. AC is equal to DC given. Can you see BC equals BC? Common. So these two triangles ABC and DBC are congruent by SSS. Okay. So that is your first step. Okay. So we can simply say triangle ABC and triangle DBC. AB equals DB. AC equals DC. Both of these are given to us. So we will write given. And then we write BC equals BC, which is common. So triangle ABC is congruent to triangle DBC by SSS theorem. Once that happens, then what will happen? Angle ABC will become equal to angle DBC. Okay. Also, angle ACB will become equal to angle DCB. Why? CPCTC. Okay. Now, if angle ABC and angle DBC are equal, then what does that mean? Both of them are half of angle ABC, because full angle ABC is this, out of which these two parts are equal. So that means what? That each angle ABC and DBC are half of ABD. Okay, this is D here, half of angle ABD. So ABD is 58, half of 58 would be 29. So now angle DBC, angle DBC, which is 2x minus 4, is equal to 29 degree. Why 29 degree? Half of 58. So 2x equals 29 plus 4, or x equals 33 by 2. Okay. So you guys will get 16.5 as the answer. Similarly, if we look at this angle ACB is equal to DCB. They have given both y plus 15 and 63. So just do that. Y plus 15 equals 63. Y equals 63 minus 15. So 63 minus 13 is a 50, and take out another 2. So 48 degree is the answer. Okay. So students, if you are watching this video for the first time, do subscribe to the channel, press the bell icon. Please like, give your invaluable comment, and share the video with your friends and classmates. Thank you.